I want to use texture triangles in my 3D graphics engine that I made in Python, but Pygame doesn't support this kind of rendering, only triangles with homogeneous flat colors. So in this video I will implement functions to draw triangles and apply the textures. And since I will draw each pixel separately, I will try to implement the Z buffer, so I don't need to order the triangles anymore. A triangle can be defined by 3 points or 3 lines, and to draw it we need to identify the points that are inside and the ones that are outside. So I'm going to start without the textures. The approach I'm going to use here, I don't know if it is the best one, but it is relatively simple, goes like this. Calculate the slopes of the lines that connect the points, go through the horizontal lines of the screen starting from the top point to the bottom point of the triangle. For each intermediate y, I will calculate the corresponding x in 2 of the lines. First for the segments before the middle point of the height, then the ones after the middle point. I just need to fill the horizontal line segments between x1 and x2, and that's it, pretty simple. So let's start with the code. I will first generate a random triangle that fits the left half of the screen. I've also created an offset here to later draw a second triangle with Pygame. Inside the main loop I will also generate random triangles every time I press the space key to see if it works with different triangles. The frame I will define as an array with the same size of the screen with 3 RGB components. The first thing is to get the order of the points from top to bottom, to know which one is on the top, the middle and the bottom. With that I can calculate the slope of each one of the lines, dividing the deltas in x by the deltas in y. First between the top and the bottom, then the top and the middle, and finally the middle and the bottom. Here I will add very small values in the denominators to avoid divisions by 0 when the points are in the same horizontal line. Then I will create a for loop to go through all the y values. Inside it I will always calculate the value of x on the line that goes from the top to the bottom point. And if y is smaller than the y of the middle point, I will calculate the x of the line that goes from the top to the middle point. If not, I will use the middle and the bottom points. I will define a different color for each case to see it better. And at the end I need to apply the color to the pixels between x1 and x2 at the height y. But before I need to know which one is on the left and which one is on the right. After drawing the triangle, I need to transform the array into a surface to be able to display it on the screen. But first I will render the same triangle with the offset applied, with Pygame's draw polygon function just for comparison. And as you can see, the two triangles look very similar. I think there is a difference of 1 pixel in the size due to the way the loops are defined, but that's okay. Applying this new method in my 3D graphics engine, where I created a new number function that draws all of the triangles at once, and with this we have a gain between 2 and 3 times in the frame rate. That's all good and stuff, but what I really want is to render triangles with textures, so that's what I'm going to do now. To apply texture I need to know the corresponding coordinates of each pixel of the triangle in the texture. One way to do this is to interpolate linearly between the points of the triangle. When we pass through all the lines of the triangle, we have to interpolate the coordinates in the 2 lines, in a similar way as it is done to calculate the values of x. But after that we need to go through all the values of x and interpolate again between the 2 new points found. Simple enough, but before all this I need to import the texture and transform it into an array. And I need to define the coordinate of each vertex of the triangle in the texture space. That is, which points of the textures correspond to the points of the triangle. Usually these coordinates are called UV, just because XY are already taken. I will work with normalized coordinates between 0 and 1, so it is easier to replace the texture later. But then I will need the texture size, which I will save in a list here to use later. Then I will define the top, middle and bottom UV points and calculate the slopes, which are the rates of change between different points. Inside the loop, again I will interpolate between the top point and the bottom point, and if the y value is smaller than the middle value, I will interpolate between the top and the middle, otherwise between the middle and the bottom. When I need to invert the x values, I also need to invert the UV values. And now I will calculate a new slope between the 2 interpolated UV values. but now in relation to x. And I will create a new loop that will go through all the values and calculate the UV coordinates in each x and apply the texture. And so we have texture triangles, which works well for any kind of triangle. So now we can apply this logic in the graphics engine. For now I will use the same texture in all triangles to make it easier. And so we can notice a sharp drop in the frame rate, getting lower than when we were using Pygame. This is because now we go through each pixel of the frame to set the color individually, whereas before we did it for the horizontal stretches with several pixels at once. But this pixel by pixel manipulation opens up the opportunity to use Z buffer, where we interpolate the Z value when interpolating the UV values. For that we need to create an array with the same size of the frame and fill it with big values to pass it to the triangle drawing function. Besides that, I need to save the distance to the camera of the projected points in the projection function. And now we don't need to order the triangles anymore. But it is still interesting to do the backface culling and calculate the shading based on the normal values. Then we just interpolate the Z values in the same way it is done for the texture and check if the new Z value of the pixel is smaller than the stored value. If it is, we will update the value of the buffer and the value of the pixel. This works relatively well, but there are some problems here. Turns out the depth relation is actually not linear, as we interpolated here. This can cause some rendering problems. But the most obvious problem is that the textures look weird, like if they are moving when the camera gets close to them. It seems kind of obvious, but I hadn't thought about that before. Squishing a triangle is not the same thing as rotating it to get the same shape, but it looks relatively fine for farther away triangles. So I need to consider the depth in a better way when interpolating. I even did some tests here, interpolating with the barycentric method and applying the correction for perspective, but I couldn't get a good result yet. I suspect it has to do with the projection method I'm using, so I think it's time to replace it with something better. But this video will stop here. If you have any questions or suggestions, leave them in the comments. You can even leave suggestions on my GitHub. Anyway, thanks for watching and I see you in the next time.